Now the next thing I want to look at is the centre of gravity. This one I took up, the centre of gravity. Now the centre of gravity, or the centre of mass of an object, is the single point that you can consider its whole weight to act through, whatever its orientation. Now the object will always balance around this point. Although it's possible for the centre of gravity to actually fall outside the object, it is actually possible to fall outside the object, it's the point at which it would actually balance. As you can see here, this is the centre of gravity for an apple. This here is the centre of gravity of a horseshoe. Do you see it falls outside its shape, but that would be the centre of gravity of that horseshoe. And this is the centre of gravity for a car. Now, how could you determine the centre of gravity for an irregular shape? An irregular shape, how would you work out the centre of gravity? Well, all you do is hang the object from a corner, hang it, and draw a vertical line straight down, as you can see here. Then you hang it from another corner and draw another vertical line down. Where they cross is the centre of gravity. So if you need to find the centre of gravity of something, draw a line down, hang it by a different angle, draw a line down, where they cross, centre of gravity. That's how you determine the centre of gravity. Now for any regular object, the centre of gravity will be its centre. As you can see there, the centre of gravity is smack in the centre. Now the height of the centre of gravity will tell you how stable an object is. An object will be stable if it's got a low centre of gravity and a wide base. Like a racing car, it's got a low centre of gravity and a wide base area. If it's long and thin, it's got a high centre of gravity, it's likely to fall over. As you can see there, that car, low centre of gravity, wide base area, it's unlikely a car is going to topple over. Now the higher the centre of gravity and the smaller the base area, the less stable the object will be. A good example is a unicycle. When a person's on a unicycle, they will have a high centre of gravity, and therefore, high as well, they will also have quite stable. It's very hard to ride. Have you tried to ride one of them bikes? They're not easy to ride because you've got a very high centre of gravity and you're tall. It's very hard to balance. Now, by knowing where the centre of gravity is, you can evaluate whether or not it's likely to top over. What's the rule then of topping over? If something's going to like to fall over, how would you know? This is the rule. If when a vertical line is drawn from the centre of gravity to the ground, if that falls outside the base area, it's going to topple over. It's likely to topple over. As you can see here, draw a vertical line down from the centre of gravity, and this here, that will not topple over. This one here will not topple over just, it might fall back. However, this one here will topple over because the centre of gravity going down has gone past the base. That likely now, that will topple over. Another one, will this box fall over? This box here, will that fall over? Well, how do you determine whether it's going to fall over or not? Well, first of all, you need to work out where the centre of gravity is, yeah? Then you draw a line down to see if it falls outside its base. In this case, as you can see, it doesn't. It doesn't fall outside its base, so this will not topple over. Will this box fall over then? How do you work it out? Centre of gravity, draw a straight line down. Does it fall outside? In that case, yes it does, it's likely to fall over. That's how you work out the centre of gravity, and that's how the importance of centre of gravity on if things will fall over.